system of equation is two or more equations graphed on the same set of axes. Two or more equations graphed on the same set of axes. Was the very last unit you did right before the exam, Unit 7. And these words hopefully will sound familiar. There were 3 ways to solve a system. You could do it by graphing, by substitution, and elimination. Ooh, it's coming back. Yeah. If you forgot it, I'll review it tomorrow. We're just going to do the graphing today. Yeah, I like elimination better too. Where we're going with this is you did linear systems because you were all about lines, but guess what we're all about now this year? So we're going to do linear quadratic and quadratic quadratic. We're going to look at the number of solutions for a linear quadratic system and a number of solutions for a quadratic quadratic system. Well, let's just go back to last semester. How many different solutions were there when you had 2 lines that crossed? So you could have 1 solution. That means they crossed once. Or more than 1, meaning more than 1 meaning more than 1 meaning infinite solutions. That's when the lines were right on top of each other. They were the exact same line. So you could have infinite, you could have 1, or you could have 0. What kind of lines did not have any kind of solution? Parallel lines. And you should have talked about what was called an incompatible system, a dependent system, and an independent system. Okay, if you forgot that, I'm reviewing it tomorrow. Not a big deal. Number of solutions for a linear quadratic. Parabola, line. How many solutions? 2. So that's one possibility. Yep. Parabola, line. How many solutions? 1. Parabola, line. Parabola's going up, line's going off this way. They will never cross. Quadratic, quadratic. Parabola. Yeah, parabola. Parabola. How many solutions? Bless you. Parabola. Parabola. How many solutions? Parabola. Parabola. And there actually is an infinite parabola-parabola system. It's when they're sitting right on top of each other, but you'll never see those. But there actually is an infinite amount of solutions. Can I turn? All we're going to do today is just the graphing solutions, and then tomorrow we'll look at elimination and substitution. So again, if you've forgotten those, no big deal, I'll go over them. Find the points of intersection of the following functions. Y equals 2x squared plus 4x minus 6, and y equals 2x minus 2. What kind of system? You betcha. One's a parabola, one's linear, so we call that a linear quadratic system. Linear quadratic. Method, step number 1. Would you like to guess step number 1? Yes, graph each function. Would you like to guess the second and last step? Yep, so mark the intersection points. If you haven't noticed, that's exactly how you did linear last semester. You just list them. It's whatever the point is, or points. Do you want to do the line first or the parabola first? Chickens. Okay. Do the line first. Yeah, and you go for the line first. -2. Okay, the quadratic, let's do it. How many ways are to graph a quadratic? 2. Which method would you like to use? Okay, what do we need to do in order to use the first method?
Change it to the vertex.
Yes, and that's called completing the square. Is there a coefficient other than 1? What should we do with it? Okay.
Divide by 2.
Oh, remember the last one we just push off to the side. You mean the more you practice, the easier something becomes? It's crazy talk.
Yes, but I mean, like, without having to write it down, like, I need to just, like, visualize it. I mean, even with like, a ton of practice, I didn't think I'd be able to do that, but during the test,
The more you do something, the easier it becomes.
I actually do this. That's weird.
You're even ahead of me there. Ooh, you're a skinny parabola. And then we just list them. And then we just list them. Offer of -2, -6. Offer of 1, 0. There we go. We have solved the linear quadratic system. Let's do it on the calc. We'll see how bright the screens are.
How do you make them brighter?
You can make them brighter, just change the contrast. Hold the second and hold the up arrow, will make it darker. And the up arrow and down arrow will make it lighter. Second and up and down arrow, depending which way you want to go. Okay, you did this with lines last semester. All we're doing now is adding parabolas. So you tell me, how did you do it last semester? Should. We're bailing on the dark policy. Alex, can you grab the lights, please? Light, please.
I mean, I could probably still do this, but yeah, it's not doing it right now.
Okay, so what do you think we should do?
Arrow does nothing.
Okay, probably we want to go into our y equals.
Can you grab both of them?
Yeah, let's graph both of them. Now, if you really wanted to tell the difference between the parabolas, you could go over and change to thick line. We don't, but you could if you really wanted to. Just because you can. You could make one a rolly ball just because you can. Now we don't hit graph. What do we go to in between? Remember? Zoom, and we pick standard. Whoosh, whoosh. So let's just sketch what we see. It doesn't have to be accurate or exact. It's just a quick sketch. So the down one's kind of like that. Up one's wider. What was the first thing we pressed when we wanted to find the vertex? Second calc. And what was the first thing we pressed when we wanted to find the y-intercept? Second calc. And what was the first thing we pressed when we wanted to find x-intercepts? And what about max and mins? All second calc. So what do you think when we want to find anything about a graph? It's always going to be second calc. We've used 1, we've used 2, we've used 3, we've used 4. Ooh, logic says 5 is intersect. Now, it's going to ask you 3 questions, just like it usually does. What it's going to ask is first curve, and you're going to say yes or no, and then second curve, yes or no, and then it will say that guess. The reason it's doing is because sometimes later on you might have 3 or 4 different equations, and the calculator needs to know which are the 2 you want me to look at. Because we only have 2, you're just going to hit enter when it says first curve. And you probably didn't notice, but what the cursor has done has jumped to the other curve, and it's just double checking, is this the curve? We're going to hit enter. Then it says guess. I don't know why. We're going to hit enter. So there's no left bound, right bound. It's just enter, enter, enter. Bam, there's the first intersection point. But how many intersection points do we have? 2 of them. So some of you might have gotten the left one. I got the right one. It just depends when your initial cursor was. So how do we get the other one? So we just repeat second function calc, 5, and just move closer to the other one. So I'm just moving to the left until I'm somewhere closer to that other x-intercept that I didn't find before. So whichever one it's closer to, that's the one the calc will find. And then it's still enter, enter, enter. Bam, there's the other one. Would have been helpful if I'd written the first one down, because now I don't remember. So negative 2.2 and 1.6. And I think it was symmetric. I'm guessing on that, though. So let's put in the box, what did we do? What was the very, very first thing that we did? Y equals. She's just like randomly saying buttons. So we put into Y1, Y2 if you need to write that step down. Then we went into Zoom. And we picked number 6. Then second function calc. And we pick 5. And that's the last thing you'll meet in this menu until grade 12, so you will never use 6 or 7 till later. It's always 1 through 5. What did we have to do to actually get the intersection points? So enter times 3. And that will give you one of them, but what did we need to do if there was a second? Just move closer. So move closer to other one, if necessary, and repeat. There's no math new from last semester. All we're adding in is just that quadratic piece. Let's do one more with the calc, one more by hand, then we'll have some time to work. What kind of system is this? Linear quadratic. How do we know? Love that. And again, repeating, anytime you use your calculator to solve something on a graph, you have to show the graph. That's the equivalent to showing your work. Doesn't have to be an accurate sketch. It's just a quick little sketch of what your calculator showed you. Pink. Second function. Calc. Number 5. Enter, enter, enter. Whoa, they don't touch. So what's the calculator trying to tell you? Hey, bozo, look at the graph. Can we find an intersection point? No, so we didn't actually need to go through those steps. If we can see from the graph, what's the answer? No solution. Don't cross. No intersection points. Last year, there was a student writing this exam, and they'd forgot their calculator, so they were already a little bit panicked. So I was like, no problem, here's a calculator, go. So it was a question like this, and he comes up, your calculator is broken. I'm like, what do you mean? Well, it's not giving me an answer. And like, how do you say? Well, it's not the calculator, it's you. So if the calculator is telling you there's no solution, there's probably no solution. Okay, calcs away, they're great, but we need to know how to work without them as well. So you're going to solve this quad system by hand. I'll give you a couple minutes with a friend, without a friend, whatever you feel like. With someone who looks friendly or not. Okay, so you're telling me, imagine I have no idea how to graph a quadratic and how to do a system. I will do whatever you tell me to do within reason. Okay. Oh, squeeze on freeze. There you go. Okay. I don't know what that means. Why?
We don't know why you told us that.
Why? 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 Oh, I so did say why.
You did not.
Oh, I so did. Oh, I so did.
Oh, now we're getting a lecture.
Oh, I so did. Oh, I meant y equals x squared. What's the point of what? But that's why we move over what we move, because it's a difference of 1 for every x. But the y's is a difference of 1, then 3, then 5, then 7.
Just do what you did.
Just,
It'll probably, I'm sure it'll take a while to, it'll take a little bit to sink in, and then once it does, you'll solve the simulator. Oh, I get that. That happens to me all the time.
oh, I would totally mess it up.
I'm like everything.
Yeah.
Yeah, that's not alright. What? Don't do that. That's spruce it up.
I know that upsets me too. That's left brain. So I'm like, bah.
If anything, I'd rather white out than just scribbling things.
Yeah, but I hate whiting out on a graph because then you don't have the little graph marks, and it's just. I can't. No, I can't. I can't. I can't. I can't. I can't. I can't.
It was an accident.
Hmm? Who had 3, 6? High five someone with their hand up.